So today we're going to learn about sum and difference formulas for trigonometry. Now there are actually two, well technically four, but there are two different ones that we're going to look at today, and that's for sine and cosine. Now there are ones for tangent, but we will not be reviewing those at this time. So just to make sure that you guys know what these are used for, they are actually used to find the value of the trig functions involving sum or differences of special angles. So, for example, on the unit circle, we only have certain special angles on there, which are your 30 degrees and your 45 degrees and then your 60 degrees and then your 90 and then all the multiples, okay? So these help us find maybe the sine of 75 degrees or the cosine of 15 degrees. All of those are not clearly on the unit circle, but we can use sums and differences to actually find those trig values. Alright, so what I have given you here are the four different sum and difference identities for you. Go ahead and pause the video and you can write them down, and then you can resume the video to listen to the explanation. So as you see, we have two different angles here, and that's what U and V are representing. They're representing two different angles, and they could be the same angles, but they're two angles. And this can actually expand to sine of the first angle times cosine of the second, plus sine of the second, cosine of the first. So basically, you rotate the angles, and then sine cosine is with the sine. Now another thing to notice is that, see how sine has a plus sign here? It also has a plus sign here. See how it's a minus here? It also has a minus here. So sine stays the same. Sine same. Cosine, on the other hand, has rotating signs. So since this was a plus, that's a minus. That's a minus, that becomes a plus. So I usually say sine same, cosine change. Okay? So it's your way of how you want to remember these. Obviously for quizzes, I'll give them to you, but for the test, you'll need to actually know it and memorize it. Alright, so let's show you how to use this, okay? A couple of things to notice is that this has sine of some angles. You know how usually we would have something here like theta? Well, that theta has been split up into these two different angles. Now, you don't have to use U and V. You can use X and Y or theta and beta. I just chose U and V as my two letters. So let me show you how this comes in handy. So the reason why we like the unit circle is that it gives us the exact values for our trig functions. So you'll know when you'll have to use this formula, the sum and difference formulas, when it asks you, hey, find the exact value of sine or cosine or etc., whatever they're asking. Now, exact value means no decimals. So if you punch this in the calculator, you're not going to get an answer. Alright, so let me show you how this works out. What we need to first think of is what two numbers will give me 75. Okay, and the only numbers that we can use are the numbers from the unit circle. So that's 0, 30, 45, 90, and etc. We only want to use the values from the unit circle because those are the values that we know already. We know that we have 1/2, square root of 2 over 2, and root 3 over 2, and 1 and 0. Okay? So we need to think, are there two numbers here that we can add together to give us 75? And yeah. 30 plus 45 gives me 75. So instead of writing cosine of 75 degrees, I'm going to write cosine of 30 degrees plus 45 degrees. Now I'm adding these because these two added together will give me that 75. So it's almost like as if I asked you to rewrite 6 in a different way. You guys could write it as 1 plus 5, or 2 plus 4, or 3 plus 3. All of those are representations of the number 6. So 30 plus 45 degrees are representing 75 degrees. Alright, so now that I know that I have cosine with a plus sign, I just follow the formula that I have right here. So I'm literally just going to copy this, but wherever I have my u's, I'm going to put 30 degrees. And wherever I have my wherever I have my v's, is where I'm going to put my 45s. So let's do that now. Now since I don't have a lot of room, I'm going to write it below. So we'll write cosine of the first one, which is 30, times cosine of the second, plus, minus, because remember it rotates signs, right? Sine of the second, which is 45, times sine of the first. So that just expands it. It just tells us what this would expand to. Alright, so now all we need to do is go to the unit circle. Okay? If you haven't already done so, make sure you pull that out. We're going to need it. Although you should have the unit circle memorized by now. So on the unit circle, cosine of 30 degrees is root 3 over 2. So I'm going to replace this function with root 3 over 2. Alright, and then on the unit circle, if you go to cosine of 45 degrees, the x value is root 2 over 2. Then we go to sine, which is also root 2 over 2. It's your y value there, and then sine of 30 degrees. That's the y value at 30 degrees, which is a positive 1/2. So for just a case, I want to explain this one more time. So cosine of 30 degrees. If I want to know what this is, it means what is the x value on the unit circle at 30 degrees. So at 30 degrees here, you see how this x value is root 3 over 2? So I am literally replacing this function with the root 3 over 2. Now I'm doing that with each one. Here's the x value at 45, see? Sine of 45, and sine of 30 degrees, which is the y value at 30 degrees. Okay? So that's from Unit 1. That was just a little bit of a refresher course for you. Alright, so let's finish this out. All we got to do is multiply these together. So when I have two fractions, I just multiply across the top and across the bottom. Alright, well, root 3 times root 2 is square root of 6. And 2 times 2 is 4. Root 2 times root 1 is just root 2. Oh, sorry, root 2 times 1 is root 2. And then 2 times 2 is 4. So some places will have you leave your answer like this. Others will want you to combine them into one fraction. I will take either one. You're going to see this answer more often though. So I would prefer this one, but they essentially are both the same answer. So if I wanted to know what cosine of 75 degrees was, I now know it is root 6 minus root 2 all over 4. That would be my exact answer. For our second example, I'm going to change two things. For the first thing, I'm going to give you a sine one instead of a cosine one. The other thing is that instead of having it in degrees, I am going to give it to you in radians. Now, you all know that if you don't like radians, you can change it into degrees. By now, you should be comfortable in radians. So I'm going to solve this using radians only. So once again, we can only use the values on the unit circle. And the values on the unit circle that are radians are different combinations of pi over 6s, pi's over 4s, pi over 3, and pi over 2. So I need to figure out which 2 would give me a denominator of 12. So remember, I'm going to be adding or subtracting these fractions, right? Which means that 2 of them, added or subtracted together, will have to give me a common denominator of 12. That's what you do when you add or subtract fractions. You find a common denominator. Well, 2 and 3 won't work, but a 3 and a 4 might work. So we have pi over 3 and a pi over 4, and we have a pi over 2 and a pi over 6. I'm just looking at the first quadrant for now. We can also do pi over 4 and pi over 6 and pi over 3 and pi over 6. I think all of those have a common denominator of 12. Now remember, our goal is to get 1/12. Okay? So let's change all of these to 12s. Okay, so I'm going to change all of them to a common denominator, just so that you guys have them listed somewhere. Now, no, I would not do this for every problem. This is just to give you guys a preview of what you should be thinking. Alright, so to get a 12 from this 3, I would have to multiply the top and bottom by 4. So this is 4 pi, and this is 3 pi. The next one would be 6 pi and 2 pi. Alright, so we've already done this one. Let's see. That would be 4 pi over 12 and 2 pi over 12. That was a... Oh, nope, I have it backwards. This should have been a 3 pi. I apologize for that. 3 pi. This one is the 4 pi over 12, and this is the 2 pi over 12. Alright, so all I did is I changed these fractions to have a common denominator of 12. Okay? And I'm sure there are different combinations for it, but, you know, we have enough pairs here to look at. So my goal is to get a 1 pi over 12 by either adding or subtracting them. Okay, well, it looks like I have this, and I also have this one, right? I don't think the others work. So with these two, if I was to subtract it, I would get pi over 12. And with these two, if I subtract it, I would also get a pi over 12. Alright, well, it turns out that either one of these will work. It doesn't matter. Now, I'm going to use the first one on my list. I'm going to use the pi over 3 and the pi over 4, which it would turn out to be the 4 pi over 12 and the 3 pi over 12, okay? So, you can use this one. It'll be the exact same answer. Alright, so now that I explained the thinking process to you, let's bring our unit circle down. We're going to need that in a little bit here. Alright, so we have sine of pi over 12, which will become sine of pi over 3 minus pi over 4, right? Now, we already know this is going to give us a pi over 12. I don't need to show the common denominator here and show that it works out, because we want these values on the unit circle. So let's break this apart. We're using the sine formula, which from our first page is this one. And we're subtracting, so I'm actually using the second one right here. So just remember it's sine, cosine, with the minus. You should have it in front of you on the notes. Alright, so it's sine of the first one, which is pi over 3, and cosine of the second one, which is pi over 4. Now my sign stays the same, so since it was a minus, it's a minus again. And it would be sine of pi over 4 and cosine of pi over 3. Alright, so now we want to go to the unit circle, which is why I had it here. Alright, so let's go to the unit circle. Where is my y value at pi over 3? Well, here's pi over 3, and my y value is right here. It's root 3 over 2. So that means that sine of pi over 3 becomes root 3 over 2. Alright, now let's find cosine of pi over 4. That's right here. Cosine is the x value, so that's root 2 over 2. Alright, now I need to go to the y value of pi over 4, which is right here. That's root 2 over 2. And cosine of pi over 3, so here's pi over 3, x value, which is 1/2. We no longer need that. Alright, so we're going to have square root of 6 over 4 minus root 2 over 4. So we get root 6 minus square root of 2 all over 4. So that is what pi over 12 equals. Alright, so our next example has you kind of working backwards. I asked you guys to find the exact value, so I still want a value like root 2 over 2, 1/2, or whatever we've been getting. So no decimals. And I gave you sine of 42, cosine of 12, cosine of 42 degrees, sine of 12 degrees. Now, 42 degrees and 12 degrees are not on the unit circle. So let's condense this. Let's go back to what it would look like with just a single form and see if that helps us out. So we can recognize that this expression fits the formula for the sine of u minus the v. So if we go back to our first page, see how this one has sine and cosine when cosine doubles up on itself? So I know it has to be one of these. And since it's a minus here, I know it's a subtraction. So I'm going to condense it by writing sine of the first angle that was listed minus the second angle that was listed. Alright, well, 42 minus 12 is 30. And sine of 30 degrees is something I know. Sine of 30 degrees is the y value, so that's going to be a 1/2. Alright, the last thing you're going to have to do with these is obviously use them with proving identities, or proving proofs in this case. So I'm going to show you how to do one of them, and I might have enough time to show you one more. So, on this one, on the left, I automatically know I'm going to be using sum and differences. How? Well, in all the other proofs that we had, we only had all x's or all thetas. We had one of the same kind of angle. In this one, you can clearly see that we have two different angles, see? And we have these nice big giant parentheses here. So our goal is to make this side look like that side. Well, it says cosine and it has a minus sign, so let's use our formula and spread this out. So we do cosine of the first angle and cosine, almost said sine, excuse me, of the second angle, which looks like it's an x. Alright, now we have to rotate my signs. Okay, remember that cosine changes. So since it was a minus, we need to change it to a plus. And we're going to do sine of the first angle and sine of the other one. Alright, let's go ahead and simplify these. So cosine of pi over 2. Pi over 2 is 90 degrees, okay? And the x value at 90 degrees is 0. So this piece right here becomes 0. I'll put it in purple. Now, cosine of x, we don't know what that is, so that just stays there. I don't know what cosine of x is. Cosine of x. Alright, sine of pi over 2. Now, sine of pi over 2 is at 90 degrees again, but it's the y value. So this becomes 1. And then sine of x we just rewrite. I don't know what that is. Alright, let's clean this up. Anything times 0 is just 0. So this whole thing becomes 0. And then 1 times sine is just sine. Okay? 0 plus sine of x is sine of x. Oh, and that is what we wanted to prove. So we have proven the identity.